Tennis is a game of skill, a game of mobility, sometimes a game of luck, but most importantly, a game of physics. Many physics concepts are hidden in each ground stroke, overhead, volley, serve, or even trick shot. Whether you're trying to put the perfect amount of topspin on the ball or making sure your serve is dangerously low but still clears the net, physics must be on your side. Gravity is one of those physics concepts that luckily, or sometimes unluckily, always occurs here on Earth.
Once you toss the ball sky high to slam the serve, it's gravity that makes sure the ball comes down. Once you lob the ball over the net to trick your opponent, it's gravity that hopefully makes sure your ball stays in the court. Once you jump up and swing your racket into position to slam the overhead, it's gravity that makes sure you come back down.
Gravity is a constant force that's always going to pull you and the ball back down to Earth.
But how exactly do you define this type of gravity? For starters, gravity is a force, and a force is any push or pull. There are two types of forces depending on the interaction of objects applying force, a contact force or a field force. A contact force involves two objects making contact or hitting one another. The second type, a field force, does not require the objects to touch, and the force may be applied at a distance. Gravitational force between masses falls into this category. Gravity may also be known informally as weight, or formally as the force due to gravity. Weight also implies the pulling on a mass near Earth's surface. In the application of gravity, it is important to acknowledge that every mass has a gravitational field. However, the amount of gravitational pull differs at differing points of reference. For example, the amount of gravitational pull on Earth will be much greater than the International Space Station. In other words, if I jump, gravity will almost immediately pull me back down from the air into the Earth, or the ground. However, the International Space Station, although still in Earth's gravitational field, experiences a weaker pull from Earth, and thus why it can remain off the surface of Earth. This is due to the nature of a gravitational field. It is really strong on Earth, but weakens the further it expands. The equation for gravity or weight is weight equals m times g. M represents the value of the mass being measured, and g represents the gravitational field strength. On Earth, this value remains constant. It is 9.80 meters per second squared. The mass of a tennis ball is 58.5 grams. Therefore, there is a constant downward pull on the tennis ball of about 576 newtons. And it is important to note that since gravity is a force, it will always be measured in newtons.
So the next time you're engaged in a heated match of tennis, don't forget the simple physics principle. And if you want to win, don't make gravity your opponent.